Right. And sharing the screen. Okay, welcome back. So we were discussing basics of Python. I know that some of you are very familiar with it, but I still decided to go through some basics through running this Jupyter notebook. And I'm trying to discuss first the Python language, and then we're going to go through Numpy, SciPy, and a few examples in SciPy. We were discussing dictionaries, which are containers, can contain your data, and they're kind of generalization of lists. In some sense, implementation of dictionaries is probably similar than lists in most platforms, but the difference is that the keys can be much more generic. I mean, generic in the sense that they can be anything that is scalar. So what are the scalar types? It can be integer, it can be floating point number, it can be a string, and the most important one, it can be tuple of integers. That to me is usually the most useful thing. For example, here we have example of two integers which are being a key, which are the keys. So for example, this could specify non-zero elements of a matrix. That's how you can think of it. Of course, strings are also useful sometimes for databases, but in computing, usually the tuples are the one that are the most useful. Okay, so once you define your generic dictionary, then what do you typically want to do with it? So, well, first, there are two ways to define it. One is to first create an empty dictionary, and then just keep adding the elements. And whenever you write this type of assignment, for example, dj of some key is equal to some value, then this element will be kind of thrown into the data type, so into the dictionary. So these dictionaries, dictionary is just being extended with each of those statements. Of course, you can also print the entire dictionary, or you can, once you define something, you can of course use it. So you can of course always print out something that you just created. Of course, if you try to print something that hasn't been assigned yet, so let's say they want to print out dj of 3,4, this is going to be an error. Why? Because dj of 3,4 doesn't exist yet, doesn't it? Okay. So now, do you have any idea how would I check if let's say certain key exists? Because many times what you want to do is you wanna say if a key, if let's say 3,4 is a key, then print it, otherwise don't. Okay, that's a very, very common thing, is to be able to check whether this key exists in an array, then do something with it. If it doesn't exist, then you probably need to add it. Okay, then maybe I need to add it. Then you say dj of 3,4 is, I don't know, something. Okay, so this is the most standard thing that you need for keys. So how would you do that? Have any idea? Anybody? Any Python expert?
You do a if statement with key comma value and then check if a value exists.
Yeah, but it's a key. It's not the value. I mean, there are two things in a dictionary. The key is what appears inside brackets, and value is what appears on the right-hand side. So first, I need to figure out whether this key exists. Now, the reason that I'm asking for this is because it turns out that there is a huge difference between Python 2 and Python 3. So in Python 2, the syntax was the following: if DJ has key 3.4, then do something. So this is how you had to do it in Python 2. Now, in Python 3, has key doesn't exist anymore. So maybe I shouldn't confuse you with that. So in Python 3, you have to do the following: 3.4 in DJ. So in other words, in usually means asking whether something is in a list. So before I execute this, I want to show you that this is a function that you typically use in a list. So let's say that they have a list. Now let me do it in here above. So insert cell above here. So let's say I have a list which is 3, 4, 7, 8, 9. Okay, and then I can ask let's say 6, 7 in A. Okay, and this is true. So that's how you check whether something is in a list. Okay, 7 in A would be true, and 10 in A should be false. That's right. So this in is very useful because you can ask whether something is in a list. And how does it work in a list is very obvious. So you just ask, is this element in a list? And then of course you could use this in if statement. If 10 in A, then print print A of no, then you might do something. Yeah, let's say print A or something. So this in is something that exists for arrays. Now in Python 3, what they did is they used exactly the same syntax for the key. Okay, this is kind of less obvious because in some sense you would expect that the syntax 3.4 in DJ would look for the pair of key and value. But no, the decision in Python community was that when you use in, you're actually comparing keys. Okay, so this statement, some variable in dictionary means is this variable key in the dictionary. Okay, so we're asking whether this is key in a dictionary, not whether this is part of a dictionary. Okay, because key in a dictionary, that's what it means. Okay, so anyway, this probably works. Yeah. So after that, we should have a dictionary. Did we print it? We can try to print afterwards dictionary, and we should see that DJ becomes something. Yeah. So here, see 3.4 now contains something because we figure out that 3.4 was not in DJ, therefore we added it. Now, when we execute this for the second time, no, it's okay. When we execute for a second time, we create a new array, a new dictionary, and again, it doesn't have that element, and then we add it here. Okay, so this is an important change from Python 2 to Python 3, therefore I'm pointing it out, how to search for particular key in a dictionary. Now, the dictionary can also be created in just one line. So if you have patience to type in a few values, you can just give them as a pair of key and value, key and value, key and value. Okay. Now this, of course, can just be used as the initialization of the dictionary. So instead of starting with an empty dictionary, you can start with some elements in there, and then you start adding them maybe in a do loop or maybe by reading to file or something, and eventually you grow the dictionary, and dictionary would then contain lots of useful data. Now, what we do very, very often is that we want to loop through the dictionary. just like through array. You know, we want to loop through array all the time. They say for I in list, do something, isn't it? So typical way of iterating through dictionary is by getting keys of the dictionary and then looping through the keys. Okay, because that of course is the most useful thing. So we can use so-called member function keys. So dictionary dot keys, and this gives a list of keys. And once we have a list, then we know what the for statement does, isn't it? For statement just iterates over the list, and we could then print a key and the value that this key is assigned to. Okay, so it's kind of pretty straightforward. Now, there is an alternative way of printing through the dictionary, of looping through the dictionary, by using so-called items routine. So if we use on the dictionary items, then it will create pairs of key value, key value, key value. So then you can use this in such a way that you can loop through key and value at the same time. Okay, so key becomes the first part of the items becomes key, the second part becomes value, and you can print the two in exact. This creates exactly the same printout. These two things give you exactly the same printout. So once more, the important point is be here once more. So we have dk, which is dictionary, and if you want to take all the keys out, you just write keys. Okay. Now, this by default, of course, just gives you an iterator over the keys. Okay, not the keys really. So if I guess if you do list, yeah, if you typecast into the list, then you actually get the list of keys. And the reason for this is that Python 3 tends to be a bit more efficient, so it does not create a list when you just iterate over list, isn't it? It doesn't give you the list because that's kind of more expensive. It gives you something that it's called iteratable. Basically, it gives you some object or a class for which you can think of like being a list, but it's not really a list. Okay, but for understanding the code, you can think of it as being a list. Iteratable object is like a list. So these are all the keys that exist inside this dictionary. But if you do items, again, it will give me an iterative object, but I can then do list on this iterative object, and then you can see what really you get. You get the pair which contains key value, key value, key value, key value, isn't it? So it's a tuple of key and value. And therefore, you understand why we can then use this in a for statement. This for statement actually, all it does is it goes through this list of key and values, isn't it? And we can print them out. Yeah, so yeah, this is pretty much all that I wanted to say about dictionaries. So here is another example where we created a dictionary in which defines like a sparse matrix. So dictionary is, let's say, an empty thing at the beginning, and then we define that only the element 100, 100, and 100, 300 has a value, and nothing else has any finite value. Pi is not defined. So I have an error, pi is not defined because I did not do from math import star. Then it doesn't know what is pi. So pi is defined in math, but it can also be defined in SkyPy and can be defined on Numpy. So any of those will define pi. Okay, so this is about the data types. We defined all important so-called scalar data types, which are integers, floating points, strings, and complex numbers. And then we defined all typical containers, which are lists and tuples and dictionaries. Arrays, of course, are coming in NumPy. Any question up to now? One thing, if you have a question, you need to immediately ask, because otherwise it might take too much time before you can ask the question. So please just unmute yourself when you have a question and just ask a question. Okay. Control flow. So control flow is kind of pretty straightforward. So we are using if sentence, isn't it? If, else, and then elif is like equivalent of else if. So that's the only kind of unusual thing that you need to remember, that elif is used instead of else if in most of other languages. So here is a typical example. You have statement 1, you have statement 2, you have statement 3. This is something that has to evaluate into the Boolean expression. Right now, we just set it to something, false or true. But in general, of course, these are complicated statements probably that evaluate to either false or true. And then we say if statement 1, then do something. If statement 2, do something else. But if statement 2 is false, then else if is called elif, do statement 3. Pretty straightforward. Now, the only non-trivial thing about these if statements is that what evaluates to false and what evaluates to true. So things that you need to remember is that an empty string, for example, would be, I forgot how it typecast. An empty string is, so that's how it typecast. You can check what means, what certain types mean. Empty string is false, but any finite string is true. Okay, so you can use, many times we use strings and checking whether we should keep, let's say, reading from a file. So you can, for example, read from a file, and as long as there's something that was read, that was successful, you can iterate. Once the reading was unsuccessful, you get an empty string, and this becomes false. So this is somehow you can stop your loop in reading, for example. Then another thing that you need to remember is the empty list, for example, evaluates to false, but any finite list with anything in it becomes true. Okay, so in terms of integers, it turns out that only 0 is false, and any other integer, 1, 10, 100, anything, becomes true. Okay, so in other words, the pattern is 0 is equivalent to false. So basically, 0 can be typecast to Boolean and becomes false. Empty list becomes false. Empty string becomes false. And empty dictionary becomes false. But everything that has something in it becomes true. Again, that's sometimes useful for iterating. Okay, so what else? We are talking about control flow, so we need to discuss then for statement. For statement is, of course, the most common way of iterating over something, and most of the for statements actually iterate over a list. And basically this function here, range, contains a list-like object. It's, of course, in this case, this object is actually, as I've discussed, this iterator object, but you can think of it as a list. And the range takes at most 3 arguments. And these 3 arguments are start, end, and the step. But of course, you can use much smaller number of arguments. So range from -3 to 3, 1, and then you typecast this into list. Of course, works like gives you a list between -3 and less than 3 with step 1. But if you skip 1, for example, we'll do exactly the same thing, because by default, the step is 1. Now, if you do just 3, then you get range of 0, 1, and 2, because the default beginning is always 0. Okay, so defaults you don't need to write because they are assumed to be standard. So the standard default is 0 and standard step is 1. But if you want something else, you have to specify. Okay, so the other possibilities, of course, for the for loop is to iterate over a list of anything. In this case, we are going over a list of words. We can then print these words, and you can create something which is called enumerate. Enumerate is actually very, very useful. Let me explain what enumerate is. So many times when you have a list, you want to have not only you don't only want to have the word or the item in a list, but you want to have an index at which this item appears. Okay, an index. So this loop here iterates over indices to the list. So we say for I in range length ls, which length of course gives you the length of the list. So we iterate with an index on the list, and then we of course can take out the successive entry in the list, which becomes word, and then we can print out that at index I we have a string of type word. Okay, so this is an obvious way of iterating over a list. However, this can be done slightly more, how can I say, efficiently, or slightly more, slightly nicer in the so-called enumerate thing. So enumerate creates from the list a tuple of two things, namely index and element. Okay, and we can then iterate through the pairs of index element in one simple loop like this. So once more, if I have ls, a second, it was defined above, ls should exist. So we have a list, and then we can do enumerate on this list ls, and this will give you, enumerate on ls will give you, as you see, pairs of index and the content of the array. Okay, and then once you have that, you know how to iterate over it. You do this. Iterator will be tuple of two things. First is index, second is the content of this array. Okay. Yeah, so this is enumerate. Next, in addition to the for loops, we also use while loops many times. I mean, it's much more seldom used. At least I don't want to use it so much, but still it exists. So it kind of works in the obvious way. While something is true, this thing is being repeated, isn't it? So I tend to not use while so much because it's dangerous. While can create an infinite loop, and infinite loops are very hard to break, and many times it's just too painful. Okay, so a much better way to do this is to write a for loop for I in range, and you put some large number, 1000, and then you say if I is bigger or equal 5, then you say break and print I. Okay, and that's just exactly the same thing, but it has a big advantage that this is never going to be an infinite loop. You write some very large number, and then you evaluate here maybe some complex expression in which you of course check whether this loop is supposed to be still iterating or not, and then you break out of the loop. So this has the advantage that it can never create an infinite loop. Of course, the disadvantage is that this number might need to be very, very large sometimes, but where nothing is infinite, isn't it? Okay, finally, yeah, the very common thing in Python is to create so-called inline loop. Okay, so instead of so let me try to create exactly the same thing first with a normal loop. So I can create an array, empty array first, and then I can say for x in range 0 to 5. Basically, I don't even need 0. I can do, for example, L1 append x square. Okay, so this kind of does obvious thing. Oops, what did I do? Print L1, yeah, Python 2 versus Python 3. Okay, so this does kind of trivial thing, isn't it? It just goes over first four integers, first 5 integers actually, and squares them. So trivial thing. Now I want to point out that this particular for loop, or any loop like that, can be created in one single line rather than 1, 2, 3 lines. Okay, and the syntax is written here. So you kind of turn around a little bit the for loop. So this part here is of course the same as above. For example, for x in range 5, and then you put on the left hand side the expression rather than in a new line. Okay, so this is the expression that you need, or operation that you want to apply on your current value. And then if you put the entire thing into square brackets, means that I'm creating inline array, or basically list. I'm creating inline list. This always creates a list, not an array, a list. And then I'm printing out exactly, I'm getting this as a result exactly the same list, Python list. So this is extremely useful because it's kind of compact and it's relatively easy to read. At least when you get used to it, it's very easy to read. So I want to create x squares for integers from 0 to 5. Okay, you know, it's very easy to read and kind of intuitive. So therefore, you will see this type of syntax a lot in Python. Now you can create so-called 2-layer or 3-layer or 4-layer for loops. So you see inside here, instead of x square, you can have another for loop, which is kind of nested, and then you can nest inside another for loop and so on. So that's possible, but it's not advisable. So single for loop is very easy to read. At least to me, it looks completely intuitive. But once you start nesting them, it gets really unreadable, and it's not advisable to use nested for loops. So single one is great, but more, it's kind of hard to understand.
Sir?
Yes?
The examples that we were doing previously of implementing Fortran or C++ with this stuff, you're saying don't use a for loop nested inside a for loop, but what if what you were to nest, you just put in C++ and then compile it together?
Just a second, your question is whether if you have several for loops, how should you do it? Is this the question, or what?
Essentially.
Okay, so I mean, if you have many do loops, you just write many do loops. That's not a problem. So you have for let's say I in range of 5, and then you have for j in range of 10, and so on and so forth. I have nothing against this loop because many times you just cannot avoid that, isn't it? That's how you need to write. What I was suggesting before is that that this thing is much more readable than the alternative, where you write something like this: for I in range of 5, let's say, but now you need to do nested do loop. I'm not even sure how to write nested do loop. Just a second. For I, and then here you do for j in range of 5, and then I think JI. Now I'm not so sure if this is going to work actually, but yeah, it does. It does work roughly what you expect. Yeah. So you see, you can nest for loops inside this inline thing. But to me, this is hard to comprehend. Okay.
So it's just a matter, it's going to do the same thing, just implementing it with a different syntax.
Yeah. All I wanted to say is that this syntax to me and to most of people that talk about Python is kind of hard to comprehend. Okay, while this, in my opinion, is easier. I mean, this is standard. You use the same in Fortran, you use the same in C, and it's readable. Okay, but when you have a single loop, then it's fine. Then I have no problem with it. Okay, but of course, this is syntactically is correct, but readability is disaster, in my opinion. And on most Python forums, they say the same thing. This can become pretty unreadable quickly. Okay, so this is all about control flow. So we now discuss functions. Yeah, so we already discussed a lot about functions. The important point is that whenever the keyword def appears, that signals that we have a function. Okay, so def means whatever is follows is a name of a function, and then the function can have several arguments. It can have no arguments, but of course function without arguments is usually useless, because we don't want to have global variables on which we apply something. We almost always need some local variables. So I don't know what would a function without arguments be useful for. Of course, the number of variables, number of arguments can be arbitrary, and the good thing in Python is that you don't need to specify what is the type of the variables. It can be anything. So this S now means that S can be integer, can be string, can be floating point, can be list, can be anything. And as long as the implementation makes sense, the code will work. So in other words, any function in Python is like something that we call template in C++, template, which means that it can be used for any type. So this function can be used for any type, as long as, of course, the syntax makes sense. So, for example, this len s might be problematic for floating points. So if you apply this function on floating point, this might give you an error. So it means that in this case, it doesn't work. But this function might work on lists and can also work on strings, because for strings, len makes sense, and for list, len makes sense, doesn't it? So what does this thing do? Well, not much, basically. So it takes, for example, a string and prints out the length of the string. The reason that I demonstrated this on this simple function is I want to demonstrate what help does. So basically, every function is advisable to have so-called documentation string at the beginning. So whenever you start writing function, please write something about this function. And the string can be either a simple string that starts with one quotation mark and ends with one quotation mark. But in this case, of course, this can be only, in this case, you can have only one line for the documentation. Many times we need several lines for documentation. In this case, the only way to do it is to have so-called 3 quotation marks. So if you start a string with 3 quotation marks, not just one, but 3 quotation marks, then it means that this is a string that can span many lines. Okay, and these strings are kind of useful in the sense that they're easy to read when you write them. You see them in the code, and they're also displayed as a multiple line string. Okay, so that's something that does not exist in C, for example, and it's useful actually. It's very useful. So 3 quotation marks means multi-line string, easy to read.
Hi, Professor.
Yes.
So does a single quotation mark or double quotation mark matter?
Yes,
Because
yes.
I say you use a double, but I think for
use-
comment one segment of code, you use single, right?
Yeah. So once more, if you have this, isn't it? This is
Yeah.
an error. That doesn't
Yeah.
work. Why?
Okay.
Because the single quotation mark can define only one line string. So then I need to have everything in one line. That now it works. Okay, but if I, of course, I mean, in C, how would you make several lines? I mean, you would need to do /n, isn't it? And then /n, for example. That would work. Okay, that syntactically is the same, but readability is disaster because the /n means new line, isn't it? You want to be able. The reason that this is useful is because you want to be able to read it, kind of when it's in the code, isn't it? And then you go into a new line and you see that this is not a string anymore. Okay, so of course you might think, okay, well, why not just create several strings like this? Okay, maybe use plus. Well, but that's basically something that needs to be evaluated and put together. I don't think this actually works. Now, this wouldn't work either because this means that I have two strings and only the first string is going to be used as my documentation, doesn't it? So therefore, in order to have documentation which or doc string which spans multiple lines, I think that the only way, or definitely the best way, but also the only way, is to have this special thing which can span several lines. So now I'm completely free to write, any number of lines. Okay.
Okay.
Very easy, and it's very readable. That's the idea. Python wants to be user-friendly. Okay. Yeah, so docstring is useful. And then multiple things, classes, or values can be returned by tuples. Yeah. Okay. So the other thing which is useful in Python, as I already said before, is that it can return several things. Like here, we can return not only length of s, but I also, let's say, return s. I mean, this is not terribly useful, but at least demonstrates the point that you don't need to create some new type or something. You can just return tuple of several things. And now I can also just, this is just going to print, well, the tuple of two things, isn't it? So, and if I want to then use this somewhere else, for example, of something, I can then do here S and L, like being unpack. So basically I can call the function on something, and then when it returns, I know that it returns two things. I can either use them as one tuple. I can have this just one tuple, isn't it? And then EE will be a tuple, or I can immediately unpack into the two components. One being the first part, which is, okay, the first part is length, I guess, and the second part is the string itself. And now from now on, I can use L and S and I know that L will become a length and S will become the string. So once more, this is just a convenience of returning several things from a function. And that's very useful because many times you kind of remember, okay, I need to return one more thing, or I need to return two more things or three more things from my function. And it's very easy just to add this to the tuple and then unpack the tuple in the code that you need. So that's something that C++, for example, doesn't have. C++ can return only a new class, and you have to define a new class. Okay. And it can also return a pair, and it can create a pair of two things on the fly, but only a pair can be created. So at most two things, not more than that. Okay. If we explicitly list the name of the arguments in the function calls, they do not need to come in the same order as in definition. Okay. This is called keyword arguments and is often very useful in function that takes a lot of optional arguments. Yeah, so what I wanted to explain here, that the function can have so-called default values. So I'm demonstrating here on this function func which in addition to first argument that we need, specify also a print, which can be set to either true or false, and then some extra variables that you might need, but not always. Sometimes you don't want to specify them, and you give them default value. Okay, so this is a way of giving a default value to certain argument. And what's very nice and special about Python is that you can specify those variables with default values in any order you want to. Okay, now why is this useful? Well, in C, for example, you can also have arguments with default values, but the big difference is that in C you have to specify them here when you call the function in exactly the same order as they were defined in a function. So in other words, this wouldn't work in C. You would need to, of course, first variable s is linked with the first argument that you give. This is str. Then needs to be followed by p and t is equal to true, for example, and then it needs to be followed by extra p. So if you don't have in C exactly the same number of arguments than needed, it's not going to work. Now, what C allows, for example, is that the very last one is not specified. So if this one is given as default, let's say the last one is given by default, you can remove this one, okay, for example, and it will work. And C allows also to remove all the variables that have default values. So this is equivalent to C. However, in C, you cannot decide that I'm going to specify only this variable, but not this variable. Okay, I cannot specify. In other words, I have to go from the left to the right. Okay, so if it turns out that I need to change this last variable, which is called extra p. Okay, so I decide extra. It's not going to be p, it's going to be q. Then I'm sorry, everything else that comes before extra needs to be specified. There is no freedom. Okay, needs to be specified. So I need to specify, I would need to specify also p and t then. Okay, however, in Python, the good thing is that you can take any argument which is default and give it any value. Okay, so I can just keep p and t to be false by default and only specify in this case this additional variable extra. Kind of obvious, huh? But why is this useful? Because let's say that I'm debugging my code, and then I want to change here print from false to true. Okay, and all of a sudden in my entire code, printing is going to be enabled. And you know, this is very useful if you debug something. So something doesn't work. Now I'm going to enable the print in only in one place, and from now on, everywhere my code will start printing lots of documentation, and I can debug and I can figure out what's going wrong. And then I just only in one place, I'm changing print to false, and from now on, I don't have printing anymore, and the debug is kind of disabled. That's extremely useful. Now imagine if I had to specify this p and t everywhere where I call the function. That would require you to make lots of changes in order to change your code from debugging to into the execution mode. So this default arguments are extremely useful, and the fact that when you call the function, you can give them in an arbitrary order is actually extremely useful too. Okay, and of course, then the function can have really many extra arguments. So you will see that in SciPy, for example, when you look at the routine in SciPy, let's say B. So from SciPy import, let's say integrate, and then you look at the help, let's say integrate quad, you will see that it has lots of arguments, isn't it? It can have, of course, you always need to specify function that you want to integrate. Quad integrates a function, isn't it? You always need to specify a function that you integrate. You need to specify the lower bound and the upper bound for the integration. But then in addition to this, you have lots of other arguments, which by default you don't touch, you don't change, but sometimes it might be useful to change. So for example, you sometimes want to change the precision of the integral, absolute precision or relative precision. Sometimes you want to change the number of recursion, you know, like doubling of the doubling of the intervals. No, doubling of the points for which you need to do the integration. So there are many other options that most of the time we don't even know about or we don't care about, but sometimes they might become useful. Okay, so therefore, and all those extra arguments are created by the so-called default arguments. Okay, and they can be specified in an arbitrary. When you call a function, you can specify them in an arbitrary order. And that's very useful because sometimes you need just one or two of them. Okay, so this is about the functions. So the other interesting thing that's kind of new in Python is so-called Lambda function or unnamed function. So many times you need a function and you don't want to create an entire new specification of the function, but you want to create it on the fly. So in C++, in the new C++ version 11, there is this same thing is called inline function because it's created on the fly, inline function. So here we call it lambda function, but again, it has the same meaning. So what does it mean? It means that this statement here creates a function, okay, not an array, but a function that is equal to x squared. So this, maybe I should start with this. So def f2. So this def f2 return x squared is kind of obvious. This just squares x, whatever you put as an input, it squares it and gives you back, doesn't it? Now, this lambda function does exactly the same thing, but with different syntax. So what does it mean? Whenever you specify lambda, it means that from now on, I'm specifying inline function. And lambda has to be followed by the list of arguments, okay, and double dot, yeah, okay. So for example, you can have x, y, z, means that x, y, and z are now arguments of the function. This is equivalent to saying x, y, and z, okay. So I can give multiple arguments, and multiple arguments in lambda function needs to appear immediately after keyword lambda. Then there is this double dot, and then is the implementation of the function, okay? Implementation of the function, dictionary function, okay? And this all appears in a single line. So kind of can be useful. Let me show you why. Now this will of course not work yet because this will not work, because I now change it so that I need three inputs. Okay, this will work. So now both F1 and F2 do the same thing. Now, why is this useful? Well, I show you before the squad function, integrate quad, which basically is just a simple integration routine in SciPy. Okay, and let's say that you want to integrate function x squared. from 0 to 1. Okay, this should give you 1/2 as a result. No, sure, 1/3, because it's x to the 3 divided by 3, isn't it? So you want to integrate x squared. Okay, and of course, one way to integrate x squared is to create a function square and then return x squared. Okay, x, and then you give, sorry, and then you give this function square to integrate quad. So integrate quad requires as a first argument a function. Okay, a function. So how do we know that? Well, because we can read documentation, help. This is integrate quad, and it says first argument is function, and that you have to have a function. And it says this function is a kind of low-level function, blah, blah, that needs to be specified somewhere. Okay, so the important point is quad needs a function, and one way is, of course, to specify the function and then use it, like we did here. But lambda function is kind of convenient here. Okay, lambda functions should never be used for some very complicated functions that are kind of spent many lines, isn't it? Because then it's not readable. But if it's a simple function, like, I don't know, sometimes you might need to do sine x over x or something, sine x divided by x, okay, and you don't want to go and create a complicated function above, but you can use so-called inline functionality to create function on the fly. Okay, this is mostly for convenience. It's not. You could always avoid this by creating another function somewhere else. Okay, so now we continue with classes. Any question up to now? This is all too simple, huh? Question? No questions. No. Okay. In terms of speed, is this too fast or too slow?
It's good.
So far? Fine. Okay, and let's continue this way. Yeah, so classes. You probably heard something about classes, but classes in Python are maybe slightly different than in C or C++. Actually, C++. C doesn't have classes. C++. Now, classes, of course, are just a kind of convenient way of packaging together variables and functions. Okay, so whenever you have a logical unit that needs some variables, you need to remember some variables, and then you need some functions that would work on these variables, then probably it's a good idea to implement this in terms of a class. So I'm trying to demonstrate this with the class point. Point has two components, x and y, and you want to do something with the point. So for example, you want to translate, you want to rotate the point.
Professor?
Yeah.
Sorry, in your markdown block, how do you format it so that it's with that gray opaque or transparent over the, like over the init? How do you format it like that?
You mean this text? Why does it appear the text? So this is markdown. You see here, markdown?
Yeah, but the part where you have like init and it's in that box kind of thing, how do you format it like that?
Yeah,
okay,
so look at
you.
this. It's very easy. So yeah, if the star appears at the beginning, then it's no, actually star means just it's a enumerate list, but this is just a simple quotation marks. Yeah, quotation marks.
Thank you.
Yep, welcome. Yeah, so we were discussing class. A class is defined by a class keyword. So whenever you specify the class, the Python will know that this is a class when you write class and then name of the class. Okay, very easy. And then there's double dot. The class contains, of course, several functions. Okay, and the name of the functions can be anything. For example, translate is a function, which is almost like a normal function that we discussed up to now by Python function, except with one difference, crucial difference. The crucial difference between the method inside the class and the normal Python function is that method starts with the special word self. Okay, so this first argument has to be self. And as long as the first argument is self, which is a special keyword, then we know that this function is not just a function, but is part of the class. Okay. Now, what does the self mean? Self, if you are familiar with C++, this is equivalent to so-called this pointer. This pointer. So this pointer means it points to the class itself. So self means actually the class, the instance of that class itself. Okay, so therefore, if I write self.x, means this is x that is data member of the class. Okay, so the class, as we discussed, has some data members, which are variables inside the class and functions inside the class. So you need to have some variables which are defined inside the class, which can be used inside the class, which are private to the class, which are part of the class. Okay, and these variables are used and defined inside the class by invoking self.name of the variable, self.x, for example. Okay, so the very interesting thing compared to C++ is that these variables, self.x, which is data member of the class, does not need to be specified somewhere on the top. So in C++, you would need to go on the top of the class and you will need to define every variable that you might use. Okay, all those variables need to be specified because these are the variables that are part of the class. In Python, you never do that. You never specify the outside or at the beginning of the class somehow the variables. You just start using them. So we start using them here and they just pop up, they appear, okay, inside the class. So therefore any function inside the class can create a new variable which will from now on be part of that class. Okay, that's very useful because somehow you don't need to go on the top and start defining a new variable. And it's kind of in Python philosophy of automatic data typing. So whenever you start using something, it immediately appears. Okay, Python figures out how to allocate the memory, how to take care of it, and when the variable goes out of scope. Okay, and it's great. The other thing, which is kind of against C++ philosophy of classes, is that any variable that you specify inside the class, such as x and y here, they are global in the sense that they can be used outside the class and they can be accessed from anywhere. Let me explain that. So I create here the point which has these data members x and y. Okay, I created them here in the initialization because I started to use them, and whenever I assign something, assign a new variable, it becomes alive. It appears. Okay, and then I can start using those x and y outside if I want to. So if p is my point, p.x and p.y are completely allowed to be used anywhere outside the class. So this is something that can be done with with Python classes only if such variables are so-called not private but public. So these are called public variables. So if you're familiar with C++, any data member in class in Python is so-called public variable. So in other words, it's visible outside. Okay, but I still didn't explain some basics of class use. So every class has a so-called constructor. Constructor just tells you how is the class being created at the very beginning. Now, if you don't specify constructor, which has the name __init__, if you don't specify that, then it's going to use default constructor that does nothing. But there's still some constructor that exists. So, but normally, almost every time that you create a class, this constructor will need to be redefined. Basically, you defined your own constructor. And what does constructor typically do? Well, so the constructor always starts with this part of the syntax. So def __init__, and self. So this part is never changed. This is what is the fixed part of the constructor, okay? Because it has to have name __init__. There's no freedom here. And then also self needs to be followed after that, because this is part of the class, okay? So up to now, no freedom. But then we have a freedom of some other possible arguments that this class might need. So point, of course, needs, let's say it's two-dimensional point, so it needs two more variables such as x and y. And then what we will do with this? Well, we might just remember these 2 points, x and y, and store them inside the class. So from now on, this x and y are kind of remembered, and they are stored inside the class variables, okay? Because from now on, self x and self y are new variables that appear inside the class as part of the class, okay? So now how do I use that? Well, here, but let me create a new item. So I have class point. I can do, whenever I write point, I'm actually invoking a constructor, okay? And point, yeah, so since this is a class, point and brackets means I'm invoking a constructor. But of course, this will not work because constructor needs at least two variables, isn't it? So I need to give point and then 2 things, whatever, 2, 3, for example. This will work, okay? So this creates a class by calling the constructor. Okay, so for example, I can print here something. You gave me x and y equal to xy, and now when I create a point, I see that this is going to be printed, doesn't it? You gave me x and y is 2 and 3. Okay, so whenever I write point like this, which is of course class, I'm invoking the constructor. Okay, that's kind of obvious. But of course, if that's the only thing that I do, this point is going to be created, but in the next line, the point will, this class or this instance of a class will immediately disappear, will be deallocated by Python. Why? Well, because nothing is pointing to it. So we created a class, but since you didn't name it, the class will go out of scope instantly. So in order to be able to use it, to do something useful to it, I need to assign it to be a variable, okay? So if I do this, q is equal to point, then this memory that's being allocated when I call constructor will actually be assigned to q, and since q didn't go out of scope yet in this part, the variable is going to be maintained, or the memory is not going to be deallocated. Okay, so only when I assign it to some variable, then I can access the content of this instance, and then I can use it. That's that. So up to now, the only thing that we did is we called the constructor, and we can do, of course, help on point that we can always do, which will print only something about the class, help on class, and then it basically just prints whatever was written here, simple class representing blah 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 blah. Okay, so this you can always do. But the question is, what useful things can be done with this class, with this point? So what can we do? Well, we define translate here. Okay, so translate, what does it do? Is it increases our x and y if we want to. Well, but first thing, we know that there is a variable self x and there is a variable self y. So inside the class, we can use self x and self y as accessing the two variables, but outside we can access them through the name of the instance times dot name of the variable. So here I need to call it q dot x and q dot y, because q is the instance of that class, isn't it? So the same variables can be accessed outside as the name of the instance of the class dot x, name of the instance of the class dot y. Inside, the same thing is called self dot x and self dot y. Okay, so now I can also do q dot translate, because translate is the member function, and I can give here 1 1, and that will well, no, this should be q, not p. Okay, so what this will do, it will add 1 to both coordinates, and when I print out, I see that they are both bigger for 1, because this internal variables 2 and 3 were translated. So this function here was called on the point, and it changed the content of self x and self y, which actually here can be accessed through qx and qy. Okay, clear? Okay, so now in addition to this special function, which is called init, which is constructor, you have several other special functions, special members of the class, and one of them is called underscore underscore str underscore underscore. So this is so-called representation of the class. So str is a method that is invoked when simple string representation of the class is needed. That's, for example, when printed. Okay, so what does it mean? Well, whenever you do something like print and q, then you want to construct from q a string, for example. And well, then the Python will ask, is there a way of translating your q into a string? And well, if this str is specified, then yes, then we know point is 3 and 4. Okay, now if this thing was not specified, okay, and I want to print q, then it will give you some strange thing, like this is actually an object, and that's with some strange code that appears at some pointer something. Okay, so completely useless output. It doesn't give you an error, but it gives you that this is some strange object. Okay, so that's completely unreadable and completely useless. But if you specify string, then I can print something useful about the content of the class. Okay, the other well, there are several other special functions. For example, representation of the class when printed. So this representation is similar than string. So it's again is used for fancy printing. And then the other one which I use a lot is called call. So it's also a special function. Now, what does the call do? Well, if you don't specify the call, let's say it doesn't exist, then if I want to, if I use Q and as a function, it gives me an error. It says, well, what does that mean? Q is a class. Okay, Q is a class. What does that mean? You're using it as a function. That's not illegal. Okay, and then if I want to give Q and some number 4.5, for example, it says again, point object is not callable. Okay, so this is an object. This is a class that you cannot call, you cannot use as a function. Okay, however, many times it's useful to use class as a function. Okay, for example, you want to integrate something, you want to use it inside this integration routine that we just used from Skype, isn't it? So maybe this is some complicated special function like Basel function or something, and you want to be able to integrate it. Okay, and you want this this class to behave as it was a variable. Okay, so in this case you specify a call thing. Okay, and maybe it can get an additional variable z, and then it might print out, let's say, or it might return three things: self x, self y, self z, for example. And now if I do q 4.5, it means that I am and this point now behaves as a function. It's called functor. This is called functor. So Q is actually a class, but can also be used as a function, which takes one additional variable, because I specify here z as the extra variable in addition to self. So this part here, the same as in constructor, it's completely fixed. There's nothing I can do about this part up to self, but then I can specify any number of additional arguments, and in this case I just want one more argument, so this 4.5 becomes the new argument, and then I return all three numbers, so 3, 4, and 4.5. Okay, so this is all about the classes. So I think we're kind of in this few minutes we mastered the class definitions and use. So to repeat once more, a class has to have a constructor that initializes the class, and you most often create certain data members with so-called self.something. You create a variable, or you can store a variable in this initialization. Then you can specify probably several variables, several functions, which are members of this class that do something, that work on these data members or change them in some way. And then there are several so-called special functions that can be used for nice printing, such as str, and that can convert a class into so-called functor that can be used as a function in a call to some other routines. Okay, so that's all about the class. Any question?
Yeah. Can you call a method defined within the class in the class at a later stage?
Can you call? But this is an example. So this is a method translate, and we are calling it here on a class. Is this what you asked?
No. Let's say we define the function translate in the class, and then can I use the same function at a later stage in the class?
Oh, okay. Yeah, sure. Okay. So your point was the following. For example, I want to use translate here.
Right.
But yeah, no problem. Self-translate.
Okay.
And you need to give, actually in this case it's interesting, you need to give again only two things. So well, yeah, I think this will okay. Or do you need to give self? Actually now I'm not completely sure. Let me check. Self-translate, that's how you use it. Now I think you don't need to give self. I think self is already given. Let's say, let's check. Yeah, I think this is how it needs to give, yeah. So not self. This will probably be an error. No, this works as well. Okay. This is how you need to do it. Basically, self dot name of the function. That definitely works. And then, of course, you need to give the extra arguments that are needed, doesn't it? Whatever. And I think self needs to be omitted here because self is always like a dummy thing that appears automatically. Okay. Any other question?
Yeah, Professor.
Yep.
So a class is just like a group of objects that all can have the same set of functions applied to them, and those functions are defined this way?
Yeah, you can think of it like this. I mean, the usual idea is the following. If you think of, you first start to think about the function, isn't that function? And then you start to think, well, okay, but it would be convenient if I have 2 or 3 functions that kind of exchange a lot of data. Okay, so let's say that all of a sudden I realized, okay, I need to have a function that translates, and I also need to have a function that does something else on the same data. And then, of course, one way to do this is to somehow store the data in an array, and then give this array to the first function, and to the second function, to the third function. Okay, that would of course work. And in Fortran, for example, that's the only way to work with it. However, in this higher order languages such as Python or C++, you want to do something that's kind of more logically contained. You want to allow this array on which you call several functions to be part of construction, which is called class, and then is going to be defined inside that class. So this array that actually will be kind of shared between different functions will become part of the class because it kind of logically fits within this object. Okay, and then these different functions will become functions inside the class. Okay, so in other words, this is a logical unit that contains functions and variables, and these functions would work on the variables. Understandable?
I think so. It's just like looking at this example, you have this class point, and then you have all these internal functions in the class that are things that you could do to points or just pull data from points.
Yeah.
Could you do the same thing with any sort of metric?
Yeah, anything. Yeah. So basically, typically what you do is you have, I don't know, several arrays. I don't know, maybe 2, 3, 4 arrays, or maybe hundreds, and some arrays. Then this array specify for you something useful. Okay, and then you have several functions that work on that arrays. And the reason that you pack them into the class is because they kind of logically fit together. You know, they represent for you some abstract object. Okay, that kind of you as a physicist means something. Okay, I mean, it's just a way of kind of making things more logical. Okay. Yeah, typical example is a plotting. For example, you have matplotlib, isn't it? You plot something, and then the class is axis. So you might throw into your axis, you know, x, and your x. You might throw on a plot, one plot. You might throw another plot. You might throw I don't know, some other graphics, some imshow. And then eventually you want to display the whole thing, okay? And all these plots are basically variables like self x and self y inside this axis. X is a class. Sorry, the axis is a class, isn't it? And then you throw on top some plots. And that's useful because you have some self-contained object, which is your thing that's going to be displayed. It's easier to think about it. So yeah, whenever you can construct logical class, it helps users to easier kind of understand what's going on in the code. Okay, so there is just one more thing that I want to talk about, but unfortunately, I think it's I guess I'll need to do it next time. So I just need to give a few sentences about modules, but I can do this next time. The idea is that we already defined now variables. We defined classes, that sometimes you want to combine all these things together into something which is another level, modules. So this is another level of making things even more modular. Therefore, they're called modules, more modular, which means that I want to have several classes and several variables and several functions packed together into a module. And typical example of a module is Numpy. Numpy is a module, isn't it? So what does Numpy have? It has multidimensional arrays. It has lots of mathematical objects, sinus, cosine, tangents, and so on. And it has lots of special functions maybe. And all this is packed together into one thing, which we call module. Okay. So, and we're going to discuss next time how to create a module and how to handle it. Okay, any question? So today is kind of the homework due. So many of you already gave me the homework, but those of you who didn't, it would be nice if you can. I'm not going to be very picky, even if you submit it after midnight, but or a few minutes after midnight. I'm not going to go to sleep before midnight, so don't worry. Okay, yeah, you can stay after the class if you want to ask a question. Otherwise, you can unzoom.